Next, we're going to look at three variable systems of equations. When solving a system that involves three equations, three variables, it's necessary for us to eliminate one of these variables so we can move this down to a two-variable, two-equation system. One thing that I want you to be careful of is that you are eliminating the same variable. I saw on our previous quiz that many times we were eliminating different variables when we were performing these calculations. The other thing that I really want us to do is to make sure that you are telling me what two equations you're using and what variable you're eliminating, just as the way that I will display as we go through this problem. Also, although you may be able to use substitution, I would prefer it if you use elimination exclusively. It's going to make it much easier to follow along with your work and make sure that you are doing this correctly. Furthermore, a lot of us made silly mistakes when it came to the three variable systems of equations. We need to be very meticulous in our work. Okay, we need to make sure that we're distributing each of our terms, that we're combining terms by adding, and that we are performing these calculations correctly. So let's take a look at this first system. So here we have x minus 3y plus 3z equals negative 4, 2x plus 3y minus z equals 15, and 4x minus 3y minus z equals 19. As I look at these, I would say that it would probably be best to eliminate y. The reason I say this is as I look at my three equations, I have negative 3y and positive 3y's. So they are already opposites of each other. And again, remember, we're going to use elimination to do so. So the first thing I'm going to do is I'm going to look at equation 1 and 2, and I'm going to eliminate y. So I'm going to write number 1 and number 2, and I'm going to write eliminate. It's doing some goofy things here. Hang on. So I'm going to have x minus 3y plus 3z equals negative 4, and I am going to have 2x plus 3y minus z equals 15. Now I don't need to multiply the entire equations by any sort of factor because I already have opposites. And basically they're additive inverses here, this negative 3y and this 3y. So they're going to cancel each other out as I combine my equations. I'm going to combine the rest by addition. So x, or 1x plus 2x is 3x. We have 3z plus negative z, or 3z minus z, is positive 2z. And we have negative 4 plus 15, so that is 11. Now we're going to do the same thing with equations 2 and 3. The reason I'm using 2 and 3 is because I again have additive inverses. So I'm going to list that I'm using equation 2, and equation 3. And again, I'm eliminating y. So we have 2x plus 3y minus z equals 15. And we also have 4x minus 3y minus z equals 19. It's perfectly fine that those z's are the same sign, because that is not what we're trying to eliminate. We're trying to eliminate the y's. So these, the 3y and negative 3y reduce, and they eliminate each other. And again, we're going to combine our other terms. 2x plus 4x is actually 6x. Negative z plus negative z is negative 2z. 15 and 19 is 34. Next, I'm going to take the two new equations and I'm going to create a new system of equations. Now, in this case, again, this worked out quite nicely because I can very easily eliminate the 2z and negative 2z. They are already opposites of each other. So if that weren't the case, I would multiply one or both of the entire equations by a factor that would then allow me to eliminate one variable. So in this case, I just am going to take my 3x plus 2z equals 11 and the 6x minus 2z equals 34, and I'm going to combine them. Again, positive 2z, negative 2z eliminate each other. Combining 3x and 6x by addition is 9x. And then I've got 11 plus 34 is 45. This works quite nicely since 9 goes into 45, and therefore we know that x is 5. Now that we know x is 5, we can take that x equals 5 and we can substitute it back into one of the two equations that were created above. I don't know, I'm going to choose to use this equation because x is just a little bit smaller here. So I'm going to take my x equals 5 and I'm going to substitute back in. So I'll take 3 times 5 plus 2z equals 11. So 15 plus 2z equals 11. Subtract the 15 from both sides. 2z is equal to 11 minus 15, which is negative 4. And z, then, when I divide both sides by 2, is negative 2. So far, I know that x is 5. I know z is negative 2. Now what I need to do, now that I have two variables, is I'm going to take those two variables and I'm going to substitute them back in to one of my original equations. So when I take a look at those original equations, the one that looks like it'd be possibly the easiest to use is this top guy here. This x minus 3y plus 3z equals negative 4. So my x is 5. Minus 3 times my y, and I don't know y yet, plus 3 times z, which is negative 2, is equal to negative 4. Just check that real quick, make sure I have that correct. Yes, I do. So let's see, we're going to have our 5 minus 3y minus 6. So 5 minus 6 is negative 1. So negative 1 plus 3y equals negative 4. Add 1 to both sides. 3y is equal to negative 3. y is equal to negative 1. Now I have all three pieces of my solution, and so my solution is x, y, and z, or the ordered triple of 5, negative 1, negative 2. So again, the key to success here is making sure that you eliminate one variable from each of those two sets of equations to get down to a two-variable system. Please try number 2.